Hello everyone, welcome back to Math Hub GH. In today's video, we are going to solve a question under laminar flow in an inclined plane or laminar flow in an inclined surface or an inclined surface. So we have the question on the board here which is going to help us understand this concept. So the question reads, oil at 20 degrees Celsius, taking our density to be 888 kilogram per meter cube, and mu, which is our dynamic viscosity, to be 0.8 kilogram per meter second, is flowing steadily through a 5 centimeter diameter and 40 meter long pipe. We should take the pressure in the inlet and the outlet to be 745 kilopascal and 97 kilopascal respectively. So now this question is asking us to find the flow rate through the pipe, assuming it's inclined at an angle of 15 degrees upwards. And also we are to determine the Reynolds number of the flow. So this question, we will first have to put out our assumptions, then we tackle the question as it follows. So our first assumption is a steady flow process. So we have a steady flow and we assume it to be incompressible. We assume the oil to be incompressible. And lastly, we can also say there is no work involved in this process. That's pump work or turbine work. We assume it to be zero because there is nothing said about that. So before we tackle this question, it has we finding for our flow rate. The formula, we have the formula which has been deduced for us already to be V naught, which is our flow rate, volume flow rate. Others could use, or other books use it Q in place of the V naught here, which is equal to the change in pressure minus rho G L, which the L is the length of the pipe, sine theta pi d for all over 128 mu L. So this is the formula we are going to use to find for our flow rate of the oil. So before we go, we tackle that question. This question can be put into 3 different forms. Where this is one form, so they can tell you it's inclined upwards or uphill at an angle. And the angle, anytime they tell you that it's inclined at an angle upward, it means the angle is going to take the positive form. It's going to take, so for instance, this 15 is going to be positive 15 degrees. And if they tell you it's downwards, it means it's going to take the negative 15 degrees if the angle there is 15 degrees. And lastly, they tell you it's horizontal, it means the angle that's going to be taken is 0. So that's how this question can also be put into 3 different forms. So now let's first tackle the first parameter we have here. That's our pressure drop or change in pressure. So we have the pressure inlet and the pressure outlet. So we can say in P1 should be our pressure inlet. P2 should be our pressure outlet. So calculating for the pressure drop, we are going to get 745 minus 97 kilopascal, which is going to give us 648 kilopascal. So we have our pressure drop here. Now we move on, putting the parameters we have into the equation to solve for our flow rate. So we have the flow rate to be equal to, we found for this that 648 times 10 to the power 3 Pascal. So times 10 to the power 3 minus rho, and our rho was given to us as 888 times acceleration due to gravity times the 40 meters, so 40 times 15 degrees. And since it's uphill, we have to use positive 15. So times 15 degrees. Close the brackets. 5 times 5 centimeters into meters is going to give us 0.05 to the power 4. And this expression all over 128 times the mu was given to us as 0.8 times 40. So we are going to get our final answer to 0.00267 meter cube per second. So this, we are done solving the first part of the question, that's the flow rate. So this is the answer we have for our flow rate.